I did civil engineering, but when you do civil engineering, you also learn about things like aeroplane aerofoils. And I've flown in planes so often, I still don't know how they fly. Well, I know why they fly, I just don't believe it. But this is why they fly. They fly because if you get air flowing over an aerofoil, you get these effectively streamlines of air or water or whatever fluid it is. And what happens is that you can see going this way over this aerofoil is longer than going this way. And there's a peculiar relationship that we can calculate in those streamlines that relates pressure and the velocity of the fluid. And essentially, the pressure plus half the density of the fluid times the velocity squared has to be a constant. So if I make the velocity bigger, it means that the pressure is less. So round here, the pressure is less on this aerofoil than it is under here. And that creates the lift. And that's what makes aeroplanes fly. I'm afraid this is a bit of mathematics. This is the equation. It's named after a very famous mathematician called Bernoulli, of whom there were about 3 or 4, I think. I don't know which one of them did it, but one of them did. And this is the pressure. It's the air pressure plus a half the density of it's the fluid pressure plus a half the density of the fluid times the velocity squared. And this is plus the density times gravity times the height. It's just in case you're looking at water at totally different levels. We weren't, in this case, essentially it's a little bit different, but not very much. So that's how aeroplanes fly. And while we're at it, we could think of how do yachts sail, because they're effectively running on an aerofoil themselves, because you're getting this air fluid coming around the outside of this sail as opposed to the inside. I've not got all the forces on this, because there are some forces to do with the keel that we've not included here, but essentially it's the same problem. And while we're at it, we might as well think about how Formula One cars are driven as well. Anybody who's a petrol head will know that all this paraphernalia at the front and this stuff at the back is all designed to force the car onto the track and improve grip. And it does it by an upside-down aerofoil. So this isn't the Russian paper I've got. It's just this is not Russian. It's the same slide as I had before, but it's upside down and back to front. And I think I've just about finished. So whatever you do with your future lives, I hope it does involve some mathematics. You'll enjoy it. If it involves engineering, that's great. If it involves going into some form of physics or accountancy or even the pure joy of mathematics, I hope you enjoy it, and I'll leave you with this.